just going to be talking in it. So the last time I saw you, we were using trig identities to evaluate other trig identities, right? You were getting something that said like tangent is equal to, say, 1/3, and then you had to find the other trig identities, right? Today, what we're talking about is using trig identities to transform from left to right. And the whole idea is that we're saying, so use trig identities to transform from left to right. And what we're doing is they're going to make a statement that says something is equal to something, and we have to show why that's true. So if I have, for example, sine of theta times, sine of theta times cosecant of theta equals 1. When it says transform from left to right, I am going to show how we got from here to 1. Does that make some sense? That I want to show how this can equal that, right? And so we have to break it down, because if you look at our trig identities, we don't have anything that says sine of theta times cosecant of theta equals 1, right? But what we do know is that cosecant of theta is the same as 1 over sine of theta, right? So if you look up there in the reciprocal identities where I highlighted, cosecant of theta equals 1 over sine of theta, which means that anywhere I have cosecant of theta, I can replace that with 1 over sine of theta, right? Because that's what equal means, right? They're interchangeable. So if I have sine of theta, but I replace this with 1 over sine of theta, which I can do, right? Because they're equal. Cosecant is equal to 1 over sine of theta. Then when I multiply that through, I wind up with sine of theta over sine of theta. And what does anything over itself equal? So we have verified that trig identity, right? We transformed it from the left side to the right side. Jameson, would you do me a favor and close that door so I don't have to listen to the maintenance guys? Will they all be this easy? Heck no. But really what you're just looking at, right, is what can I move around to make this work? Now, if I have something that's more like, let's look at B. I'll bring this down with us so we can see it while we're working, right? If I have can't write today. Parentheses cosecant of theta plus cotangent of theta times cosecant of theta minus cotangent of theta. Well, this is like having a binomial times a binomial, right? We haven't dealt with any of this yet, but we can actually multiply those through. Now, if I look at those right away, I think, oh, those are a difference of squares. But even if you don't know that, you guys know how to multiply binomials, right? Or at least you better, because you learned it in Algebra 1. Then we did it again in Algebra 2. And then I think we did it a little bit again in early pre-calculus when we were still talking about algebra. And some of you might remember the term FOIL, although if you had me for math, I didn't teach it to you because I hate it. But what it means is that we're going to take this first piece and we're going to multiply it times this first piece, right? We're just going to multiply these through. Cosecant of theta times cosecant of theta is just cosecant of theta squared. If I multiply cosecant of theta times negative cotangent of theta, I just wind up with minus cosecant theta times cotangent theta, right? They don't combine together. All I can do is multiply them times each other. They're not like terms. They can't be. So I've multiplied this cosecant times everything in the other binomial, right? So I'm going to do the same thing right here. I'm going to go cotangent of theta times cosecant of theta. All right, well, that's just going to be plus. Does it matter what order I put it in? No, because they're multiplied. So I'm just going to write it as cosecant of theta times cotangent of theta. And then I'm going to multiply cotangent times negative cotangent of theta. And I'm going to get minus cotangent squared theta. If you look at these center terms, right, I have minus cosecant theta, cotangent theta, plus cosecant, cotangent theta. What that allows us to do is eliminate them, right? If I subtract something from the same thing, we just wind up with 0. So these actually cancel each other out, right? Minus cosecant theta, cotangent theta, plus cosecant theta, cotangent theta. It's hard to say, it's a mouthful. But you can see that they're the same, right? One is positive, one's negative. They just become 0. And so what I'm left with here is cosecant squared theta minus cotangent squared theta. And if you look at our Pythagorean identities, we have this one right here. This says 1 plus cotangent theta squared theta equals cosecant squared theta, right? If I have 1 plus cotangent squared theta equals cosecant squared theta, and I just subtract this over to the other side, you would see that 1 equals cosecant squared theta minus cotangent squared theta. Do I need to write all that? No. But what it does tell me is that this is equal to 1. And so we did verify that this whole thing equals 1. And I forgot to write that part in there, that that's what we were trying to prove, which could be a problem, right? If I don't tell you what you're trying to equal to.
It's a lot of work just to figure that out.
It really wasn't, though, because this was the only work we had to do. I mean, it was really just one line, and then we
There's a lot of
simplified.
writing to figure out.
Well, there's a lot of writing in the explanation of it.
Yeah.
But do you have to do all that writing? Well, yeah, you have to do all this,
Yeah.
right? But you know, it's pre-calculus. It should be a little bit of work, right? All of your problems are gonna kind of be like this. You'll probably have some that you have to multiply through like this. Be organized in it, right? If you keep yourself organized when you're solving these problems, it will really, really help you, because a lot of it is just keeping track of what's in front of you. So if you're sloppy with your math, it's really easy to lose track of where you're going, right? But all of them will be kind of like that. You'll have something that's set up equal to something else, and you have to show how it works. And look, I mean, I even screwed up the second example because I forgot to put the equals one up there. I'm like, what are you trying to show? I was all excited about multiplying through those things that I forgot to put the equals one at the top. After that, all you're going to get is application problems. Application problems are word problems. I find when I am dealing with word problems, drawing pictures is the best thing I can possibly do to get some kind of visual of what's going on, right? More often than not, though, your homework's going to draw the pictures for you, right? So that you have some kind of a visual representation of what's going on when we're applying these trig identities. And let's bring this down again because it will come in handy. Actually, it might not. You know what will come in really handy?
What?
Some old hippie
Well,
caught another hippie tripping on acid, right? Because we're dealing with solving these triangles now. And a lot of times what you're going to be given is some kind of a right triangle, and you're going to be given parts and asked to find the other part. So, for instance, say I've got a guy, right, a surveyor, that is standing 115 feet away from the Washington Monument. Now I have to try and draw the Washington Monument. That's it. That's as good as I get. It comes to a point on the top, and it's like a long thing. It looks like a big pencil, right? Here's the ground underneath the Washington Monument. Here is the dude. Right? He's a surveyor, and he is 115 feet away from the National Monument, from the base. He knows that the angle of elevation from where he is to the top of the monument is 78.3 degrees. And he needs to find out how tall the monument is, right? So this is what he needs to find, right? He needs to find this height. If I have something like this, well, what do I know? I know that my angle right here is 78.3. I'm going to write that here just so you can see the numbers a little better. 78.3 degrees. We know this distance from him to here is 115 feet. So we know the adjacent, right? The adjacent angle is the adjacent length is 115 feet, right? We don't know the opposite side, right? That's what we're trying to figure out. Opposite equals question mark. That's what we're trying to find out. So we know that we have a degree, right? So we have to look at this angle and we go, well, based on this, what would I use? Sine, cosine, or tangent? I have an adjacent and I need to find the opposite.
tangent.
So tangent, right. The one that has adjacent and opposite is tangent. Opposite over adjacent. So I'm going to go tangent of 78.3 degrees equals, well, the opposite over the adjacent. We don't know the opposite yet. So I'm just calling it x over the adjacent, which we do know, which is 115 feet. Now, if you guys remember how to isolate that x when it's in the bottom of a fraction, we would just multiply both sides by 115, right? And what we would get is 115 tangent of 78.3 degrees equals x. And so all we have to do is plug this into a calculator. Now, if you don't know how to do them both at the same time, that is fine. I know my calculators, the ones that I have in the classroom and can't seem to find right now. Hold on, I'll be right back. There's one over there, even though I already know the answer. I just wanted this to become an action movie all of a sudden instead of just a regular old video. On my calculator, you can plug that in as it is, right? I could just go 115 and then hit the tangent button and a parentheses will open. Now, I don't know if you can see that. Probably not, but literally I just put in 115 and I hit the button that said tangent and it opened a parentheses, which will allow me to put the degree in it. And when I hit enter, I get 555 feet. It's 555.31 feet. And so I get x equals approximately 555 feet. Now, if you don't know how to work your calculator, look up the directions when you're dealing with tangent or sine or cosine. But literally all you have to do is hit tangent and it should offer you the degrees. So if it should offer you a parentheses to put in whatever the degree is or whatever the radian is. None of this is going to be mental math. You're going to have to do it all by hand. I mean, by calculator, right? You can't figure out the tangent of 78.3 degrees in your head.
If you want to bet.
Well, I can't figure out the tangent of 78.3 degrees in my head. And I'd bet a lot on that because I know me. And so we figured out that the Washington Monument is 555 feet tall, right? Approximately 0.31 feet. So like and a third feet. Some of these, like my next one says we got a lighthouse 200 yards from a bike path, right? So let's say this is my bike path. Call that bike path. And say right here, I have a lighthouse, right? And that the distance from this lighthouse to the bike path is, what did I say? 200 yards. There's a walkway to the lighthouse that is 400 yards long. So let's make this walkway. This is just a walkway to the lighthouse, walkway. And we're saying that that is 400 yards long. They want to find the angle. They want us to find the angle between the bike path and the walkway. Find angle between bike path and walkway. So this is the angle we're looking for, right? This is the theta that we don't know. We need to find that theta. So from this, what we do know is that we have the opposite, right? If you look up, the side opposite that angle is 200 yards, right? So we know we have the opposite and we have the hypotenuse. So if I'm looking at my Sokotoa, my some old hippie who caught another hippie tripping on acid, I have the opposite available to me and the hypotenuse available to me. What I'm looking for is the theta. So I would use sine. Does that make some sense? Right? The two pieces we know are the opposite and the hypotenuse. So I'm definitely going to use the one that has opposite and hypotenuse, right? What do we not know? We don't know the theta. We know that sine of theta equals the opposite over the hypotenuse. And we know that the opposite and the hypotenuse are 200 over 400, right? So I can say that sine of theta equals 200 or 400. We could reduce that to 2/4, right? Which reduces down to 1/2. Does anyone remember what sine theta equals 1/2 is in degrees? We went over this one when we. What's that?
Or I know there's a number in there.
It's a degree. Remember when we're on the unit circle?
Wait.
It lands somewhere. There's like an X, Y value, right? If I do this, if you remember correctly, sine equals Y, right?
Yes.
And if you remember when we had these acute angles at 30 degrees
Wasn't that like 90?
and at 60 degrees, we had 1/2 radical 3/2. And at 30 degrees, we had radical 3/2, 1/2. So
That makes sense.
theta equals 30 degrees. Use your unit circle. I'll post one for you if you need it into Power School, because it'll make your life so much easier if you just have that available to you instead of having to like plug in the inverse function into your calculator, right? Yeah, you definitely want to be able to work with those. What if I have a skate ramp, right? I actually built the most beautiful half pipe. I used to have this 3-car garage, and across the entire length of the 3-car garage, I had this 4-foot half pipe that was amazing. And then we moved and it didn't fit in my new garage. And my daughter sold it for Taylor Swift tickets. Sorry, I was reminiscing about that little heartache right there. So say I have a skate ramp. Ooh, pretty steep. That's supposed to be a right angle. Oh, thank you for straightening that up for me there, computer. So I have a skate ramp, and I know that this angle of elevation is 18.4 degrees, right? And I know that from here to here is 13 feet. And I need to find the side lengths of B and C. So this is all the information I'm given, right? Any idea where I might start looking. Now, I'm pretty sure I'd start with one of these, right? Some old hippie caught another hippie tripping on acid, right? Any ideas where I might start? What do I have? What side length do I have from that angle? Do I have the opposite, adjacent, or hypotenuse? I have the adjacent, right? Yeah, it's actually connected, right? The opposite is the one opposite of the angle. So B is the opposite. So if I have the opposite and I want to if I have the adjacent and I want to find the opposite, I would use tangent, right? If I have the adjacent and I want to find the hypotenuse, right? C, I would use cosine. Does that make sense? So we're going to use two different ones. We're going to use one to find the hypotenuse, and we're going to use the other one to find the opposite. Does that make sense to you a little bit? So let's start with B. If I want to find B, I want to find the opposite. Well, I have the adjacent, so I'm going to use tangent, right? Because I know that tangent equals the opposite over the adjacent. And I know what the adjacent is, and I know what the angle, the theta for tangent is. So all I have to do to find B is go, well, tangent of 18.4 degrees equals B, right, which is our opposite, over 13 feet. So I'm going to multiply both sides times 13 just to get rid of that fraction, right? And I wind up with 13 tangent 18.4 degrees equals B. So to find that side length, all we have to do is plug that into the calculator like we did before, right? And we are going to get, I don't remember what we're going to get. I actually have to look. We're going to get approximately 4.3. So we're going to say that B equals 4.3 feet. We've solved that one, right? For C, we're going to use cosine, right? Because we were given the adjacent and we need to find the hypotenuse. At this point, couldn't I use sine as well? Because now I know what the opposite is. Right? Now I can use anything I want. But if I had been solving it in the opposite order, because I could choose either one, right? I could have solved C first. So I'm going to go as though I don't even know what B is, but I could use 4.3 if I want. I could do it that way right now, right? I could go, okay, well, I've got the opposite and the adjacent. Once I solved B, I've got both sides, so I can use that to solve, right? I could go, um, oh no, I need a hypotenuse to do it. I actually have to do it this way. I actually have to use either cosine or sine, right? I'm going to use cosine. Why? Because I can. So what do I know? I know that cosine of theta equals the opposite, the adjacent over the hypotenuse, right? So cosine of 18.4 degrees equals 13 over C. right? So when we clear out that fraction, what do we do normally? We multiply both sides by the denominator, right, to get rid of that fraction. So I'm going to do that. I'm going to multiply this times c. I'm going to multiply this times c. And I'm going to get c times cosine 18.4 degrees equals 13. But I can't just plug in c cosine 18.4. We're really trying to get that c by itself because that's what we're solving for. So we're just going to go ahead and divide out cosine of 18.4 degrees from both sides. And so what we know now is c equals 13 divided by cosine of 18.4 degrees. This now is something you can plug into a calculator. You can hit 13 divided by, and then in parentheses put cosine of 18.4 degrees, right? What do you get when you do it? About 13.7 feet. I don't know why I wrote 4. I said 7. I wrote 4. So we know now that this is 13.7 feet. If it was something smaller than B, or what we know is the adjacent side, we know we did something wrong. Why? Because it's the hypotenuse. The hypotenuse has to be our longest side, right? Because think about that. The square A squared plus B squared equals C squared, right? So C ought to be bigger than A and B. Play with these a little bit. Remember, they're all sine, cosine, and tangent. You can make all of them happen just with these right here. All right. Any of those word problems that you get are going to work with sine, cosine, and tangent. You don't have to scour the earth trying to figure them out, right? They all work with this. So figure out what you're looking for and what you have in all of these problems, right? If you have a hypotenuse and an angle, use sine or cosine, right? You could do either one to figure out your opposite or your adjacent, right? If you have the opposite, you can use tangent or sine, right? Depending on what you have, right? Depending on what angle side you're given or you're looking for, right? Play with them a little bit. I'm not going to give you a ton of them as homework problems, but really you only need 3 different things to solve them, right? You need to know sine, cosine, or tangent, and how to manipulate, right? How to solve for a variable, really, right? Which will either be an A side, a B side, a C side, or theta itself. That is all I have for you. When you feel like pulling your hair out, doing the homework, feel free to message me. I will be happy to open up a Google Meet whenever I can get in and help you out with that. I'm going to stop recording right now.